Hi everyone, I'm Roxana Espinosa, and today I will walk you through an IR spectroscopy exercise. We'll break down an IR spectrum, identify key functional groups, and figure out what molecule we are dealing with. Okay, let's get started. Next slide. Okay, IR spectroscopy helps us identify functional groups by looking at how different peaks we have. And how different bonds absorb infrared light. Here are the most important ones that we need to know before figuring out which molecule we have. So the first, OH stretch means like alcohols and acids. And the broad peaks are between the 3200 and the 3600 centimeters. Now the CH stretch, that means alkanes, and aromatic bonds. And that's between the 2800 and the 3100 centimeters minus 1, exponent minus 1. Now the C double bond A stretch means carbonyl groups, and the strong peaks are between the 1700 centimeters minus 1. Now the C8 stretch is between the alcohols, ethers, and esters, and that's in between the 1000 and the 1300 centimeters minus 1. Now, with this information, we can figure out which molecule we have. Now, to the next slide, we can see, looking at this IR spectrum, the biggest clue is the strong peak is in the 1715 centimeters minus 1. This tells us there is a carbonyl group, like a C double bond A stretch, meaning our compound could be a ketone, aldehyde, or something similar to that. It could not be, there is no OH stretch on the peaks, so because it doesn't go to the 3200, 3600, so it's not an alcohol and it's not an acid. Now, the CH stretching at 2900 centimeters minus 1 means we have an alkyl groups, like methyl groups. Okay. Putting this together, we can confidently say that this spectrum belongs to acetone, a simple ketone. Now, there are below 1500 centimeters minus 1, and it's called a fingerprint region, okay? And it's super complex with tons of small peaks from it. It's like it has a lot of peaks like this, okay? From CC, bonds of CC, bonds of CH. So we don't use for functional groups, but it helps confirm a molecule once we already suspect what it could be. For acetone, we see some peaks here, but nothing that changes our conclusion. It's still acetone, okay? It's still a ketone. Now, let's compare acetone to a propanol. And here's what's the difference. From a broad of OH stretch at 3,350 centimeters minus 1, confirms that it's an alcohol group, and we don't go that far with this molecule, with this IR spectrum. CH stretch at 2900 and 3000 centimeters minus 1 means that it's an alkyl group. We can expect what it is. That was expected. And a COH stretch at 1000 and 1300 centimeters minus 1 tells us that it is an alcohol and not a ketone. So while acetone has a C double bond A at 1715 centimeters minus 1, propanol has an OH at 3,350 centimeters minus 1. And a COH stretch, that's how we can tell them apart. That's how we know that it's not an alcohol. Okay, to sum it up, to finish, IR spectroscopy helps us quickly figure out the functional groups that are in the molecule. The C double bond O peak at 1715 centimeters tells us we have an acetone, while the broad of OH peak at 3,315 centimeters confirm propanol as an alcohol. And that's it. Thanks for watching, and I hope this helps you for your exam, and let me know if you have any questions. I'll change to the next person.